you have before you is comprised of a vacuum pump, a vacuum gauge, and a vacuum chamber to place material in for experiments. The vacuum gauge is calibrated in millibar and in altitude. And as you can see, the pointing to sea level, or 1013 millibar. We're going to now turn on the vacuum pump, and we'll show you how the pressure is reduced in the chamber. As we close the air and vent valve, you can see the pressure falls to approximately 1 millibar, or an altitude of 140,000 feet. At this pressure level, some very interesting experiments can be done. We have placed 2 balloons on the base plate, and as you can see, the yellow balloon is open. The blue balloon has been tied with a knot, and there's a little bit of air inside the balloon. We will now place the chamber over the base plate, and we will now start to evacuate the chamber and observe the balloons. Okay, we will close the isolation valve now, and when we do that, contained in the chamber, and as you see, the blue balloon that was sealed has expanded greatly due to the pressure being reduced in the vacuum chamber. And although you can't see it too well, the yellow balloon that was open is still very, very small. Okay, what we'll do now is we'll admit air to the chamber. What happens, observe the 2 balloons again. And as you see, as we admit atmospheric pressure, the blue balloon comes back down to its normal size, and of course the yellow balloon is still the way it was. Right? So we are basically able to control the vacuum chamber from atmosphere, something below atmospheric pressure, and as you see, that can certainly create some interesting phenomena. We will now remove some air from the water bottle through the opening. We'll place the water bottle on the vacuum connection on the chamber, and when we open up the valve, observe pressure can do. As you can see, the bottle was crushed very, very quickly. Now we'll close the valve, and we can pull that apparatus up, and as you see, the bottle was very nicely and efficiently crushed. That's atmospheric pressure doing some work. We now will demonstrate sound in a vacuum, and what we have is a 6-volt bell mounted on the vacuum base plate, and we will now engage the bell with the 6-volt battery. And as you can see, it's pretty loud. Okay, now we will put the vacuum chamber, and you can still hopefully hear it. And now I'm going to basically zoom in on the vacuum gauge. We will now open the vacuum valve and keep an eye on the vacuum chamber pressure, and at the same time if you can listen for the bell, as the pressure is reduced, we're now near 100 elevation, or 1 millibar. We will now turn off the power to the vacuum pump. And as you see or hear, there is no sound. All right, so we'll basically pull back and we'll zoom in on the bell. Now the clanger is still moving, and actually you can see a small amount of a kind of a bluish green arc, which means that light can transmit through a vacuum, but sound will not. So at this stage we'll now admit air to the vacuum chamber. Now we're back to atmospheric. If we can see and hear, the sound has basically been there all along. So, as you can see, sound is transmitted by air, and if there is no air, there is no sound. We will now place some marshmallows in the vacuum chamber. What happens to them as we remove the air from the chamber. So we will open the vacuum chamber and observe the marshmallows. And as you see, they've expanded. All right. So they have increased their volume. And what we're going to do now is we're going to close the vacuum isolation valve, and we're going to bring the chamber back to atmospheric pressure, and again, observing the marshmallows. Okay, now let's remove the chamber, and we'll just kind of grab one of those marshmallows on with the toothpicks and kind of give it a... As you can see, the atmospheric pressure certainly works on them. So marshmallows in a vacuum don't survive very well. What we have here is a Easter carryover. This is a marshmallow peep, all right, from Easter time, and we're going to basically subject this marshmallow peep to a vacuum. So we'll place the vacuum chamber over the marshmallow peep very carefully, and we will now open the vacuum valve and expose the peep to vacuum and observe what happens to the marshmallow peep. I would say it's growing. It certainly has expanded quite a bit. All right, so what we're going to do now is we're going to close the vacuum valve, and we're going to observe the peep when we admit air back to the chamber. So we'll start admitting air and see what happens. It looks like we have a peep. Let's remove the chamber. And I don't know, I'll see if I can get a close-up of that. But we have one squished peep. Kind of a fun thing to do.